Alright, welcome to Chapter 9. This first section is 9.1, the square root property and completing the square. So in Chapter 9, we are dealing with quadratic equations again. This time we're stepping away from factoring though. We're going to do some different equations, and obviously they're equations, not expressions. Equations that cannot be factored, so we'll have to solve them some other way. So let's start with reminding ourselves what a quadratic equation looks like. Quadratic equation starts with ax squared plus bx plus c equals 0, right? This is our standard form of the equation. And where a, b, and c are just numbers, so you might see them like 2x squared plus 4x plus 9 equals 0. That's a very classic quadratic equation, something like that. That's written in our standard form. Remember, when you solve these, you get two answers, right? You end up getting, when we factored them, we ended up getting two pairs of things equal to 0. And then we use zero product property in order to solve for those two things. We would get something like x equals 5 or 10 or negative 6 or 2, stuff like that. And then if we had more complex equations, we'd have to check that both of those actually worked. But here, we can kind of guarantee our two answers. Same idea goes no matter what kind of a quadratic you have. Even if you can't factor it, it will still have two answers, okay? And it all kind of bases around that idea we were talking about last chapter with the regular root and the the principal root and the negative root, right? So since we have two things that when we take the square root of both sides, we end up getting, technically there's two answers, right? Remember, we got 36. Square root of that could be both 6, or the square root of 36 could be negative 6. And so that's how we get our two answers here in these quadratic equations. It's because of that principal rule. Alright, so let's start with something called the square root property. It's kind of what we've been talking about. It says you can take the square root of both sides. Very, very similar to the power property of equality, where you can take powers to both sides, right? So if you can take a square to both sides, then there's no reason you can't take a square root to both sides. It's the same idea. And we can use that to solve some equations. Okay, so let's take a look at this first equation. Pretty classic, pretty straightforward. X squared equals 16. So I have x squared equals 16. Square root property says I can take the square root of both sides as long as I consider the positive and negative version. So I'm going to take the square root of both sides here. And then this cancels that, as we've seen before in the last chapter. And we get x on this side. When I take the square root of the 16, though, I have to remember that there are two things that equals the square root of 16, both 4 and negative 4. Sometimes if you want to save space, you'll see this written as plus or minus 4. So here, x is equal to plus or minus 4. And that makes sense, right? Because we just saw this in like the 36 example. Both of those squared would give me 16. Alright, let's try it again. X squared equals 5. X squared equals 5. Again, I will take the square root of both sides. These two cancel. I end up with x. And then over here, I have plus or minus. Now I can't actually reduce that to anything but a decimal, so I'm just going to keep it as the square root of 5. X equals plus or minus 5. Sorry, plus or minus square root 5. Plus or minus root 5. Alright, so far so good. Sometimes you have additional things you need to take care of as well, just like we've seen in all the other solving equations, right? Again, the basic philosophy is start as far away from the variable as you can. Start as far away from the variable as you can. So I'm going to start by adding 50 to both sides, get rid of that guy first. X squared is equal to 50, and then I will take care of the 50 part. Take care of the squared part. So I'll take the square root of both sides. I get x is equal to plus or minus 50, right? By the square root property, I have to have that plus or minus, right? It has to be positive. Oh, sorry, not 50. Square root of 50. Has to be plus square root of 50 and minus square root of 50. Same reason it had to be plus or minus 4. And then 50, I do believe, reduces. So we've got 10 and 5 and 2 and 5. Okay, I've got a pair here because my index is 2. I'm looking for pairs. Ends up being 5 root 2. So x is equal to, let's put it over here, plus or minus 5 root 2. And yes, plus or minus 5 root 2 is the only form I will take. Okay. Okay, let's try one more. One more. And then we'll do a word problem. Oops, that's not what I meant to do. Okay, again, same concept still applies. I'll start as far away from the variable as I can. Plus 48 to both sides. I end up getting 4x squared equals 48. And again, I'm going to go as far away from the variable as I can. That squared is actually on the variable, so I don't want to take the square root yet. First, I'm going to divide by 4 to make my life easier. So I go over here, I get x squared is equal to 12. Now I can take the square root. So a square root of both sides leaves me an x on this side, and a plus or minus square root of 12. Square root of 12 can be reduced to 3 and 4, 2 and 2. Got a pair of 2's I could pull out. So that's equal to plus or minus 2 root 3. If this part right here is very ambiguous to you, you have no idea what's going on, then you need to go back to section 8.3 and check out simplifying radicals. Okay, so check out the video for simplifying radicals, 8.3. That's what this part is right here. Okay, so that's the square root property. Basically just tacks on that plus or minus, right? Otherwise, it's a pretty straightforward property. Let's see how it works in a word problem. Galileo Galilei, born 1568, died 1642, developed a formula for freely falling objects described by d distance equals 16t squared, where d is the distance in the feet the object falls, disregarding air resistance, and in t seconds, regardless of weight. I want to shove Kanye West off the Leaning Tower of Pisa to test this formula. I do every day. If the Leaning Tower of Pisa is about 180 feet tall, use Galileo's formula to determine how long it would take for West to hit the ground. Okay, so we've got this Leaning Tower of Pisa, right? Whoops. Leaning Tower of Pisa. Maybe it's not that dramatic, but it seems like it. Here's West up here at the top, chilling with his stupid white t-shirts that cost $300. And then I want to push him off and I want to see when he hits the ground. Okay. So straight free-falling object. That would be West here with his little douchebag smile. And here is my formula for Galileo's falling objects, right? Here's my formula for Galileo's falling objects. That's something I should probably underline. And I should also underline what it means, where d is the distance in feet and t seconds, right? For t seconds. I want to know, okay, so then they tell me that the Leaning Tower of Pisa is 180 feet tall. 180 feet tall, right? And I want to use the formula to determine how long it would take for him to hit the ground. So all 180 feet he's going to fall, right? And I want to say how long. Okay, so this is our translate part. I drew a picture. I underlined some stuff. Let's keep going with that translate. Let's take our equation, see what we can fill in. Let's see. They gave me one number, and I have two variables. Which one could that be? 180 feet tall. Is that going to be a distance or a time? That's going to be a distance, right? So 180 feet equals 16t squared, right? So he's going to travel all 180 feet in that amount of time. Now I can go ahead and solve. Divide by 16, right? Start farther away from the variable. 180 divided by 16 would be 11.25 is equal to t squared. Now I can take the square root of both sides. It's about plus or minus 3.35. Yeah, 3535. We'll go there. Is equal to t. So that's my solution, right? That's my solution. Now I'm going to translate back. What was t? T was in seconds. Only one of these answers makes sense because technically I have two answers here, right? I have a positive 3.35 seconds or a negative 3.35 seconds by the square root property. I have one or the other. Which one actually makes sense? The positive one, because it's time, right? We'll just circle it as our answer. 3.35 seconds. So it's going to take him 3.35 seconds to actually hit the ground. Hopefully that's enough time for me to run away before the cops come get me. Alright, cool. So that was a fun little example of where you would apply this to real life. The next thing we're going to do is very, very similar. It's, again, the square root property, but it's slightly larger format. So no longer is just the variable being squared. It's actually a whole binomial being squared. And let's see how that plays out. So I've got this equation right here, 2x minus 3 squared, quantity squared, equals 18. So the whole thing squared. But again, it's the same product, or the same property, right? It says if you take the square root of a side, then nothing changes, right? If you take the square root of an entire side, that's why in our last example we waited until the square root was all by itself, right? And in our last stuff we waited until the square root was all by itself. That way we can get rid of it, take the whole side, right? We've seen this kind of before when we were doing squares of both sides in the last chapter. So let's just rewrite our equation here. 2x minus 3 quantity squared. That's what you'll hear me say when I say this whole parentheses being squared, quantity squared. And I'm going to take the square root of both sides. When I do that, I end up with just a 2x minus 3 on this side. Very similar to how we were canceling the radicals with a square in the last section. Equals plus or minus the square root of 18. I still have to do that plus or minus on the other side. Here I don't have to because it was squared, right? Here I don't have to because it was squared. But here it's just an 18. I have no idea if you mean the positive version or the negative version, right? So I have to put the plus or minus. I can reduce that 18, but I think I'm going to wait until the end. Until I do, I'm going to do all my reducing at the end so I don't have to do it like 5 or 6 times. I'm just going to do it at the end. Next I'm going to solve for x. So I'll add 3 to both sides. I get 2x is equal to, now those two I actually can't combine, right? That's a complex, or not a complex, that's a radical expression now. I have a 3 and a root 18, right? So I can't actually combine those. So I'll just put 3 plus or minus root 18. 18. And then the very last thing, I'll divide by 2 to both sides. I'm going to write it up here. So I have x equals 3 plus or minus the square root of 18 over 2. Alrighty, Teddy. Now I'm going to simplify that 18 just to make sure nothing cancels. Remember at the very end, or like near the end of our last chapter, we talked about simplifying these things, talked about simplifying them and getting rid of some common factors. We're going to do that here as well. And if you have no idea what I'm talking about, go back and check out 8.5, 8.6, 8.7, somewhere in there. It's about there. Okay, so then we will factor this down. That's 9 and 2, 3 and 3. It looks like 3 root 2. 3 root 2. So I can rewrite this as x equals 3 plus or minus 3 root 2 over 2. And, okay, I actually can't cancel anything that would help me, so that will be our final answer. But I did have to simplify that 18 just to check, just to make sure. Okay, let's try another one. So I've got this bad boy now. 3x minus 9 quantity squared plus 6, right? First off, the whole side is not being squared. We can see this is slightly different from the last problem. But again, let's just start as far away from the variable as we can. So we'll start minus 6, 3x minus 9 squared is what's left over after these two cancel. And it looks like these two cancel on the other side as well, but you know, that's okay. If it equals 0, that's okay. I just can't divide by 0, right? I just can't divide by 0. Now I can take the square root of both sides. I end up with 3x minus 9 equals plus or minus the square root of 0. Hold the phone just a sec. The square root of 0. Remember, 0 is the only number in the universe that is neither positive or negative. It's kind of the wall between the two, right? You can't, like when you stand on the state line, right? You're not really technically in either state. You're not really, you're technically in both states, right? So think of 0 as like the state line. It doesn't have a positive or a negative. So how can I find the positive and negative version of it? I really can't. The square root of 0 is just going to be 0. So I'm going to simplify that. And then there is no positive and negative version. So this is probably the only, not probably, it is the only number that will not have to worry about the plus or minus, the square root property, because it doesn't have a positive or negative version. It only has one. So for this one, we're only going to end up with one answer. And that's okay. That's okay. Alright, so we can go ahead and solve this guy now. 3x minus 9 equals 0. Just rewrote it up here for some room. Add 9 to both sides. You end up with 3x is equal to 9. And so x is equal to 3, and that's our one singleton answer. Cool. Now you may be thinking, Miss K, there's one answer up here, x equals. No, technically there's two answers up here, right? Technically, this last problem had 3 plus 3 root 2 over 2, and 3 minus 3 root 2 over 2. If you're going to forget that those are two separate things, you may not want to write it this way. You may want to write it like this. You can even put curly brackets around it to remind yourself it's both, okay? So this one actually had two answers. This is the only case where x equals, or this whole thing equals 0, that we get x equals 3 is our only answer. Okay, so if you have a square root of 0, that's the only one that's going to have a singleton answer. Okay, let's try another one. Again, we have something extra on this side. Let's do a big blue. Something extra on this side we should take care of first. So let's subtract 8 from both sides. We end up with 4x plus 16 quantity squared equals 7. Okay, good. That's a 7. That's not going to be a singleton answer, right? So it's now when I take the square root, it's not going to be a problem. But let's go ahead and do that. I'll take the square root of both sides. I end up with just what's left over under the radical, the radicand. 4x plus 16 is equal to plus or minus the square root of 7. Plus or minus the square root of 7. Heading up here, I've got 4x, whoops, I'm just going to copy it down real fast, plus 16 is equal to plus or minus square root of 7. Now I can move that 16 over, I end up with 4x equals negative 16 plus or minus the square root of 7, and then divide it by 4. And I end up with the answer of the two answers of x equals negative 16 plus the square root of 7 over 4 and negative 16 minus the square root of 7 over 4, which I can combine to negative 16 plus or minus the square root of 7 over 4. Square root of 7 is a prime, don't have to whittle that down. And unfortunately, since there's no 4 right here, there's no factor of 4 right here in front of the 7, I can't reduce the 16 and the 4, right? Because it has to be to both of them. Has to be to both of them. Like I could technically write it like this in two separate fractions, and then I could reduce it to negative 4 plus or minus the square root of 7 over 4. I could do that. It's not very pretty. So it's up to you. You'll probably see this version on the test before you'll see that version on the test. Alright, let's keep going. Do another one. Luckily, okay, so now this one, I have the x plus 3 quantity squared equals 11. The whole side is being squared, so I can just jump straight to square root property. X plus 3 squared is equal to 11. I can take the square root of both sides. I'm left with x plus 3 is equal to plus or minus the square root of 11. Then I can move the 3 over. I'm left with x is equal to minus 3 plus or minus the square root of 11. And 11 is prime, so I am finished. Last one. Again, I have a quantity, 2x plus 4, all being squared on one side and a 10 on the other. So I can take the square root of both sides. I end up with 2x plus 4 is equal to plus or minus the square root of 10. 10 may not be a prime, but it is no longer reducible, right? The only two factors are 2 and 5, and neither one of those can split anymore. I don't see a pair, so square root of 10 is as far as I can go. Now subtract 4 from both sides. I'm getting 2x is equal to minus 4 plus or minus root 10, and divide by 2. Final answer, x is equal to negative 4 plus or minus square root of 10 over 2. And once again, I do not want to factor this down anymore because the 10 is under the radical. Just because 10 can be divided by 2 doesn't mean that it's on the outside, right? This is not 10, this is the square root of 10. Square root of 10 is 3.16, and 3.16 is not divisible by 2. Okay. So that's handling stuff like this where it's not just an x being squared, it's more of a whole quantity being squared. But again, the concept is the same. Start as far away from the variable as you can, try to get the square by itself, deal with square root property, then keep going with all your other algebra rules. Alright, so that's the first part of this chapter, nice and straightforward, kind of introduces this square root property thing. We're going to use it now to do something called complete the square. Complete the square. As always, the name tells you what we're going to do. The name is trying to tell you how this thing works. So let's remind ourselves of one thing first. A special case. Perfect square trinomials. Yes, they're back. Perfect square trinomials. What that says is that when you have a trinomial and you have squares on both sides and 2 times the outsides in the middle, then you get that thing squared. So in other words, if I had a square here and a square here, and then this one is 2 times this square, 2ab, I can factor into ax plus b squared. Okay. Let's try another one. So x squared plus 6x plus 9. Okay, so my x is being squared, my 9 is a square, 9 is 3 squared, right? And then I just have to check that the middle is 2 times 3, the a is 1, times 1, it's 6. So this would factor into x plus 3 squared. That's just a little mini review on this. If you need more of a review, check out Perfect Square Trinomials 6.3. 6.3, okay? So what we're going to do now is we're going to look at stuff specifically like this. We're going to say, okay, we've got these quadratic forms. We want to change them into the squared forms we were just working with in the last, 10 minutes, okay? So we want to change it to something that looks like this. That's what we want to change it to. That's the idea. Complete the square. That's the square they're talking about. This is the square they're talking about, okay? How do we do that? Well, let's just dive in. The steps are right here for you, but let's just dive in and check it out because I feel like it's easier to see when you're working with numbers. We have x squared plus 8x minus 20 equals 0. Clearly, this is not a whole side being squared, right? It's not a quantity being squared. It's just got that one little x squared in the front. So what I want to do is I want it to get to something like this. X plus or minus something equals a number. That's my goal. That's my goal. Because then I can just take the square root property. I can do what we did in the last chapter. Right now, that's not going to happen. If I factor this thing, it's not going to be a perfect square. So what I'm going to do is I'm going to slightly change it so that it is a perfect square. I'm going to take this 20 and I'm going to kick it out. I'm going to kick out that 20. I need the room. And by kick it out, I mean move to the other side. So I've moved this 20 to the other side. Everything else stays the same. 20 plus 0 equal to 20. Okay? So I just kind of made myself a little space for c. Now, I want to stick a new c in here, a new constant, that when I factor, I end up getting a square, right? So what I want to do is I want to take b, let's see, if you remember, this is a, b, and c. So I'm going to take b, and I'm going to do it over here. And I know that the middle is supposed to equal 2 times b times, or 2 times the outsides, right? And if I want to know what the outsides are, then I just have to divide by 2. Because I know it's the special case is times by 2. So I'm going to divide by 2. In this case, 8 divided by 2 is 4, right? And then I know that the ends are supposed to be a square of that. I know the ends are supposed to be the square of the number, so I'm going to square it. So I'm going to do b over 2 squared. So 4 squared is 16. This is going to be my new c, my new constant. I'm going to go ahead and stick that here, 16. Alrighty? Cool. What I do to one side, though, I must do to the other, so I must make this side 16 as well. That's just a property of equality. I have to do that. Alright, so once again, what I've done is I've said, okay, I need this to be a special case. I need there to be a perfect square here and 2 times a number here, right? It's got to be perfect square to the end, 2 times that same number in the middle. The number that would do that would be 4, right? It would be 8 divided by 2, and then I square it, and I stick the 16 in. The reason I've done that is now let's factor this. What would this be? Okay, now it's a special case, right? Now I've got 2 times 4, so this would be x plus 4 squared. That was my goal. I wanted this to factor into x plus 4 squared. Over on the other side, I have that equaling 20 plus 16 is 36. Now it looks like the form where we were just solving, right? Now it's got a whole quantity being squared on one side. Much, much easier to solve from here, okay? So what I've done is sort of manipulated this quadratic so that it ended up not being the classic standard form quadratic. It ended up being one of these guys. From here I can just solve. So square root both sides. I get x plus 4 is equal to plus or minus plus or minus square root of 36. And I can actually, we'll reduce at the end. And then I subtract the 4 over. X is equal to negative 4 plus or minus the square root of 36. Now we reduce. We always reduce at the end, right? Reduce at the end so you don't have to worry about whether you need to reduce once or twice or whatever. Alright, square root of 36 is a nice whole number. Negative 4 plus or minus 6. And remember, it's two answers. So what this says is x is equal to negative 4 plus 6, or x is equal to negative 4 minus 6. Negative 4 plus 6 is 2, or x is equal to negative 10. Notice how just as the same with our factoring, we rarely end up with plus or minus 6, right? We actually end up with 2 or negative 10 as our final answer. And that's complete the square. So just change the quadratic to make it square rootable, if that's a word. Square rootable has a bunch of hyphens in it. Let's do another one. X squared plus 6x plus 3 equals 0. We'll start by taking this one and getting it out of the way. X squared plus 6x is equal to negative 3. The question is what do we want to stick here now that we end up getting something like x plus 4 squared? Well, I'll take b, because I know it's supposed to be 2 times something, right? B is 2 times the number I want. B is equal to 2 times my my number in question. Just draw a little number symbol. So I'm going to take 2 over b to find that number. That number would be 6 divided by 2, or 3. And then I want to square it to put it at the end. So it'll be 9 plus 9. Alright, over on the right hand side we'll add another 9 as well, right? Because what we do to one side we must do to the other. This now factors because it's a special case, x plus 3 squared is equal to, over on this side, 6. Sweet. I'm going to grab this equation, I'm just going to rewrite it over here. X plus 3 squared is equal to 6. Then I'll take the square root of both sides. I get x plus 3 is equal to plus or minus square root of 6. So x is equal to negative 3 plus or minus the square root of 6. 6 only factors into 2 and 3, so I can't reduce that anymore. I can't get it to a whole number, can't even reduce it. So technically my two answers are sitting right here. X equals minus 3 plus root 6, and x equals minus 3 minus root 6. And that's our answers. Fabulous. Let's keep going. Try again. Do it a couple more times. So again, I'm going to throw this guy out. Throw him out. So I've got x squared plus 13x plus a space equals 3. Now I need to figure out what to put there. Okay, this one, well, let's just figure it. This 13 is supposed to be 2 times the number I want, right? 2 times the number it'll factor to. And so the number that I need is 13 over 2. In order to square it, I can use my distribution property. I get 13 squared is 169 over 4 squared, or over 2 squared is 4, right? Yeah, it's a fraction. Big whoop, don't care. So I'll put a fraction there. Plus 169 over 4 is equal to 3. Alright, now that might be a little hard to factor by special case, maybe hard to see, but as we've seen in the last 4 problems, the number that I end up dividing by 2, or get for after dividing by 2, where did this one go? Ends up being the number in my factor. Same thing goes here. The number I divided by 2 ends up being the number of my factor. So this is just going to be x plus the number I got when I divided by 2, 13 over 2 squared is equal to, and then over here we had to add another 169 over 4. My apologies for leaving that off. Let's go do that over here. Yeah, let's just make sure to save some space for a second. So I've got 3 plus 169 over 4. How many fourths is 3? That would be 12 fourths plus 169 over 4. It's going to be, I believe, 181. Yep, 181. So that equals to 181 over 4. That should be familiar from chapter 7, right? So this is going to equal 181 over 4. So now we can square root both sides. I'm going to drag and drop that over here. X plus 13 is what 13 over 2 is what's left over after we square root both sides. This is exactly the same as if it was an integer, right? It's exactly the same. I just had to add a fraction. Oh well. Is equal to plus or minus the square root of 181 over 4. Then I can subtract that to the other side. Negative 13 over 2 plus or minus square root 181 over 4. And then I can simplify. It looks like I can simplify that. Remember that quotient rule that says I can square root the top and square root the bottom? So when I do that, I end up with x equals negative 13 plus or minus the square root of 181 over 2. Because square root of 4 factors down to 2, and then I can put them over the same thing of 2. And that's my final answer. Alrighty. Let's do another one. Not in yellow, because that's yours. Okay, so I have x squared plus 20x equals 200, or plus 200 equals 299. I'm going to start by getting rid of the c, minus 200 to both sides, right? X squared plus 20x is equal to 99. Now I need to figure out what to put here, right? So b over 2 is going to be 20 over 2, which is 10. 10 squared is equal to 100. So we'll put in plus 100 to both sides. Plus 100 to both sides. This left-hand side factors into x plus that thing we got over 2, right? b over 2, which is 10 squared, is equal to 199. Now I can take the square root of both sides. I end up with x plus 10 equals plus or minus the square root of 199. And then subtract the 10 over, you get x is equal to negative 10 plus or minus square root of 199. And 199 is actually prime, so it does not factor. We are finished. Okay. Hopefully this is starting to become a little more fluent as to why I'm doing these steps, right? Remember, I'm trying to get the c out of the way so that I can make this kind of statement, and then I can solve that using the square root property at the beginning of the section. So let's do another one. I can move the c out of the way, get x squared plus 5x is equal to 1. It's going to be another fraction one. b over 2 is equal to 5 over 2, right? Then I square that. Get 25 over 4 ends up going into the slots. Plus 25 over 4 to both sides. And I've kind of rewritten my equation now. I know this one's going to factor to x plus that thing over 2. 5 over 2, b over 2, squared. And 1 plus 25 fourths. Let's see, 25 fourths. Let's So 1 would be 4/4 plus 25/4. That's going to be 29/4. Alrighty, sounds good. Lots of fourths going on here, and that's okay. Square root both sides. End up with x plus 5/2 is equal to plus or minus the square root of 29/4. And then we subtract that 5/2. Notice I'm not even touching the square root part until the very end. I just reduce once, so I don't have to reduce a whole bunch of times. Square root of 29/4. Now I can reduce, since x is all by itself. I notice the square root of 4 will become 2. So this is x equals -5 plus or minus square root of 29/4. Since square root of 29 is square root of 29 is a prime, right? I can call it a day, and that's my answer. Alrighty. One last one we need to talk about. This f guy right here. So one last one for complete the square. Then we'll talk about some things that don't work. This one is only different slightly because a here is not equal to 1. I don't know if you noticed, but in every single one of our last examples, a was equal to 1. In other words, there was no coefficient in front of x. If there is a coefficient in front of x, then this doesn't work, right? This doesn't work straight from the get-go. But it's an easy fix. All you have to do is get rid of a. So divide by 2. I end up with x squared minus 2x minus 6 equals 0. And from there, I can do complete the square, okay? So it only works if there are squares on both sides, right? That's the whole point here is we're going off of perfect square trinomials. That's not a perfect square, that 2 right there. So that messes me up. I can't use it. It's never going to be a perfect square unless I get rid of it. So I got rid of it, and now I've got a square on this side, this x side, right? A 1 is a square. So now I can just keep going with the process here. So if you ever have an a in front, you just got to get rid of it by dividing by whatever it is. If it was 6, divide by 6 to everything. If it's a -1/2, divide by -1/2 to everything, right? So do what you have to so that a is equal to 1. From here, we can just repeat this, complete the square idea. So plus 6 to both sides to get rid of that one, right? We end up with x squared minus 2x is equal to 6. Now what are we going to put there? Well, I've got a minus 2, so b over 2 is going to be -2 over 2. It's going to be equal to -1. No, it's not -1. Square that, and that becomes 1. So 1 positive 1's what we're going to put here. This factors into that thing we got as b over 2. So x minus 1 squared. Yeah, this one's a minus this time. That's okay, right? If what you end up getting over 2 is a negative, that's fine. Like, no big deal, whatever. Just a negative in the factored form, too. And then over here, 6 plus 1 is 7. Then we will square root both sides. X minus 1 is equal to plus or minus the square root of 7. Oh, good, that's a prime. Not that I would worry about it now. I'd worry about it later. And I get x is equal to positive 1 plus or minus the square root of 7, which is no longer reducible and is my final answer. My final 2 answers, right? X plus root, or 1 plus root 7, 1 minus root 7. Okie doke. Moving right along. We are going to try and solve these using complete the square. Let's see what happens. Actually, we don't even need to use complete the square on this first one. Let's just use square root property, right? Because we don't have an x in the way, right? It's not a quadratic. So we don't need to use complete the square here. We can just take the square root of both sides. Well, first let's rewrite the equation. So I've got x squared equals -15. That's just a rewrite for me because my handwriting's big. Square root both sides. You end up with x is equal to plus or minus the square root of 15. Oh, no it's not. -15. Talked about this at the end of the last chapter, right? So we have -15 under the square root. We can reduce that by using one of Miss K's favorite things, I square root of 15. 15 is not reducible itself, so we'll just leave it as it is. Alright. Remember, if you forgot everything about I, that's section 8.7. Feel free to go check out the videos on those. Let's try it again. Let's try one of those quantity squared ones. So I've got x plus 2 squared is equal to negative 16. Take the square root of both sides. I get x plus 2 is equal to plus or minus square root of negative 16. Do not forget that plus or minus part. Even if it's complex, even if you've done 50 of these, do not forget the plus or minus part because you need two answers, right? You need two things that can be squared. And I'm not going to reduce this negative 16 thing yet. I'm going to wait until x is all by itself. So subtract 2 from both sides. I get negative 2 plus or minus the square root of negative 16. Now I can go ahead and subtract the 2, or reduce the 16, pardon me. So I can rewrite this as x equals negative 2 plus or minus. We call this square root of negative 1 times the square root of 16. Or in other words, x equals negative 2 plus or minus I times 4. And just to make it a little prettier, x equals negative 2 plus or minus 4i. Complex answer, but that's okay. I still have two numbers, right? A complex number is still a number. It's not a real number, but it's a number, right? I got two answers, negative 2 plus 4i, negative 2 minus 4i. Fabulous. So let's do one more with complete the square. Okay, so again, I know I need to complete the square here because I've got a three-term quadratic, right? I've got a quadratic that has an x in it, not just an x squared. If it's only got x squared, then you can use square root property. But unfortunately, that singleton x kind of throws that game off. So why don't we just rewrite it as a quantity squared using complete the square. So I'll take the take the 7 out. Now it's a negative 7 on the other side, right? I need to fill something in here. So b over 2 is going to be, let's see, b was 2. Over 2 is going to be 1. Square that, that's equal to 1. So I'm going to throw a plus 1 on both sides. This is going to factor into x plus that thing I got for b over 2. b over 2 was 1. Squared is equal to negative 6. Alright, looking good, looking good. Now it's a whole quantity squared on one side, so I can take the square root on both sides. And I get x plus 1 here, and the square root of minus 6 here. Okay, we can see that might be an I issue later, but we're not going to deal with it right now. We're just, I don't know why I put parentheses around this guy. Those are no longer needed. Anyways, I got x plus 1. I can do one more step to get minus 1 plus or minus the square root negative 6. Just move that 1 to the other side. And negative 6 could not be reduced, right? 2 and 3, I'm not going to find any pairs in there. But at least I can pull out the I. So my final answer would be x equals negative 1 plus or minus I root 6. That would be my final two answers. Alrighty, hopefully that answered some of your questions about complete the square and square root property. If not, shoot me an email and I'd be happy to help you out. I'll see you in the next video.